Hi, our users. In this video, I want to show you causal analysis using R with more sophisticated DAGs. First, I want to introduce the library SimDAG to simulate DAG models, DAG data. So the syntax is empty underscore DAG parentheses, that's the template. And then you can add the root nodes, age and sex. Age is normal distribution from with mean 50 and standard deviation 10. Node is sex, it's a Bernoulli with probability of success being 0.5. And then you can define a child node. So for example, a continuous node BMI, it depends on age and sex. So it's a Gaussian distribution. The parents are age and sex. This is the formula to generate for the value for BMI and with error of 5. Similarly, you can define smoker, but it's a binomial. And then you get a formula like that using the logistic regression model to generate smoker. And similarly, you can generate the blood pressure, you can generate heart disease, and then you set a random seed. You generate the simul data using sim underscore from underscore DAG on the DAG object, and number of simulation equal to 1,000. And this is what it looked like for the first few rows. Okay. So after we generate this DAG model, we can DAG data. We can using do some visualization using ggDAG and the ggplot2. So we can use the function dagify by using dagify and specify the relation BMI generated from age and sex, smoker from age and sex, etc., etc. And we need to specifically tell our exposure smoker and the outcome is heart disease. And then let's reload GG2 plot. Then we use the ggDAG on the DAG underscore object, theme DAG, set it up, and then the GG title. So on the right-hand side, you can see it's generated a DAG visualization for simulated data. Okay, that's the DAG model we specified. We can also do minimal adjustment sets. So we can load a library called DAGnity and then ggDAG. We can define the DAG in DAGnity. So we use the function DAG. So DAG underscore code, you use single quote. Then DAG, you use these pathways. And then you process it using DAGnity, the DAG code into DAG object. You have to tell R specifically smoker is the exposure and heart disease is the outcome. Okay. So to find the minimal adjustment set, you use adjustment sets function. Then you can print it out and give you two sets, age and BMI or age and sex. Okay, so first we try the first set, and then we can do the visualization using gdag underscore adjustment underscore set, then specify exposure to smoker, outcome of the heart disease, shadow equal to true, using that. So it gave you these plots, minimal adjustment sets visualization. So one is for using age and BMI, the other is age and sex. The adjusted is in orange color and the unadjusted is in light green color. Okay. All right. I can do a little bit of further analysis using minimal adjustment set. For example, we choose the age and BMI. We can do a logistic regression. So using the age and BMI as additional covariates to smoker to predict heart disease. And then we can print out the outcome, and you can see the p-value for smoker true is 0.9925. So it's not, smoking is not significant effect on heart disease after controlling for age and BMI. Okay. Okay, and a little bit more is we can do DAG-T and the ggDAG. We can define the syntax with coordinates for better plotting. So we can DAG-D, and we can define these variables with positioning, and then the pathways, and then we can specifically tell the coordinates, and then we can plot it out. If you don't do the coordinates, the graph is like squeezed into the upper area and doesn't look very nice. Similarly, we can use the ggplot2, use the ggDAG to generate plots with ggplot2 style. So much easier, look like that. Okay. Next one is I want to show you how to check D-separation. So the question is BMI a confounder that blocks backdoor path? D-separation is a graphical criterion that tells you whether two variables are conditionally independent given a set of other variables based on the structure of a causal DAG. So basically, this saying if the effect of smoking on heart disease 100% going through BMI, okay, and that's what it means. So we can run this D-separated DAG in the smoker heart disease, and then the third one is the BMI. We can put more than one potential variable there, okay. So here we just test BMI, and the R tells us it's false. So BMI is not a D-separator, okay. Second one is we can use the implied conditional independencies function to list all testable conditional independencies implied by the DAG. Okay, so and this is give us a long list of things. So what this means is, say for example, age and BLD. I think that's blood pressure. Age and blood pressure are independent of each other if we condition on BMI in the smoker. Okay? And age and the sex are independent of each other. Blood pressure and the sex are conditionally independent given BMI in the smoker, things like some the interpretation like that. So the nice thing is it gives us all the testable conditional independencies in this DAG model. Okay. And also identify all minimal sufficient sets. I think we did this before. It's kind of redundant, but yeah, here's again. And also we can find the instrumental variables. Instrument variable must be associated with exposure smoker, but affects the outcome only through this exposure and not via confounding passes. Okay, so what this means is so here is there any variable that associated with smoker and heart disease, but it only kind of influence smokers. Okay, so we can use the instrumental variable on DAG object, exposure smoker, outcome equal to heart disease. We can print it out. Oh, so this tells us the sex is that variable. It only impacts smoking, condition on the age and BMI. Sex is only affecting heart disease through smoking status. Okay. All right, we can do some other visualize minimum sets. The first one, and visualize without manually passing the coordinates. Remember we did that. That here we can do something just by doing this ggDAG adjustment set. Okay, and then we can also just using manual coordinates doing that. And then we can plot adjusted sets and then print it out. It's very similar to previously, but there's different ways you can do that. Okay. This is a little bit more is export DAG to text file for use outside R. So if you want to do something else with other software on this DAG model, you can use the write.lines as character of DAG and give the name. It will save on in the default directory of your R. Of course, you can give more specific path to the directory you want to save this object. All right. Okay, I just want to say DAG is very complicated. I try to also find some way to add a latent variable to DAG and do some analysis of it, and it ended up too complicated um, to me to finish on time. So I think I'll just try it in the future. Thanks for watching, and you're welcome to ask any questions here, and also please share this video with anyone you think that may be interested in, and also please like our video, subscribe to the channel to support our learning channel here. Thank you so much.